Today we're going to take a look at graphing quadratics in standard form. By the end of this video, you should be able to graph a quadratic in standard form and be able to write the equation in standard form given the graph. First, you should know that when an equation is written in standard form, it will look like y equals ax squared plus bx plus c. Now the steps for graphing a quadratic that's written in standard form are quite different from the steps for vertex form. The first thing we need to do is find the axis of symmetry. And you do that using the formula x equals negative b over 2a. You get a and b from the equation, and then axis of symmetry is always written as x equals a number because it's the equation of a line. Step 2 is to find the vertex. With vertex form, we found the vertex first and then found the axis of symmetry. And the axis of symmetry was the x-coordinate of the vertex. So this time we're working backwards. We're going to use whatever our axis of symmetry was, so negative b over 2a, as our x-coordinate of our vertex. And then to find the y-coordinate, you need to plug that value in for x in the equation. The next thing we need to find is the y-intercept. The y-intercept is the easiest thing to find in standard form. It is always going to be the point 0, c. In fact, for any y-intercept, you plug 0 in for x, and then whatever your answer is the y-intercept. So when you plug 0 in standard form, all you're left with is c. So it's the point 0, c. And then step 4 is to go ahead and graph. Now, A is going to do the same thing that it did in vertex form. It will stretch the graph or flip it upside down if it's negative. So we're going to plot the vertex and the y-intercept and then use A to fill in the rest of the points. So we're going to graph using the vertex and A. So let's take a look at a few examples. For this first example, we have the equation y equals negative x squared plus 2x plus 3. So I'm going to go ahead and write out what a, b, and c are. So a is the coefficient of x squared, which is negative 1. B is the coefficient of x, which is 2. And c is the constant, so it's the number without the x, so that's 3. We know that we should always find the axis of symmetry first, which is x equals negative b over 2a. So if I plug a and b into that equation, I have negative 2 over 2 times negative 1, which will give me negative 2 over negative 2. So my axis of symmetry is x equals 1. And I can go ahead and graph that on my graph. The next thing we need to do is find the vertex. So we know that 1 is the x-coordinate of our vertex. Now I'm going to show you how to do this by hand and how to use the calculator. So if you're just plugging 1 in for x, you could say you have negative 1 squared plus 2 times 1 plus 3. And that gives you 1 squared is 1, so negative 1 plus 2 plus 3 gives you 4. If you want to double check that on your calculator, you can use the store button. So you can say you're going to store 1 for x, and then type in the equation, which is negative x squared plus 2x plus 3, which gives you 4. Either way is fine. If you're more comfortable using the calculator, do that. If you're more comfortable doing it by hand, then do it that way. So I can go ahead and plot that point on my graph. The next thing we need to find is our y-intercept, which is always the point 0, c. Since c is 3, our y-intercept is 0, 3. Now make sure that you write it as the point 0, 3 and not just the number 3. Then the next thing we need to do is use a to help us finish graphing our parabola. So since a is negative 1, we know that the parabola is going to be flipped upside down. So if we look at our vertex, which is this blue point, we went over 1 and down 1 to get the y-intercept. And since parabolas are symmetric, you can go over 1 and down 1 on the other side to also get a point on your parabola. Then if we remember the pattern for quadratics, you go over 2, then usually you go up 4, but since a is negative 1, we're going to go down 4. Then usually we go over 3 and up 9, but since a is negative 1, we're going to go down 9. And then we can go ahead and connect the points to form our parabola. And now that we have graphed the parabola, we can go ahead and figure out the roots, the domain, the range, and the end behavior. Remember that roots are the same thing as x-intercepts, which are these 2 points here, which are negative 1, 0, and 3, 0. Remember that domain is how far to the left and how far to the right the graph goes, and for every quadratic, your domain is negative infinity to infinity, or all real numbers. Then range is how low and how high the graph goes, so it will go all the way down to negative infinity if we continue the graph, and it goes up to 4. And then our end behavior is our last thing. We always start out as x approaches negative infinity, f of x approaches blank, and as x approaches positive infinity, f of x approaches blank. So if we look at this graph, both ends of the quadratic are pointing down. So both of these, the left side and the right side, will approach negative infinity. Let's take a look at another example. So this equation is y equals 2x squared minus 4x plus 3. So if I write out what a, b, and c are, a is 2 because that's the coefficient of x squared. B is negative 4 because that's the coefficient of x, and then the constant is 3. The first thing we need to find is our axis of symmetry. So we're going to do negative b over 2a. So negative b, since b is already negative 4, negative 4 is positive 4 over 2 times a. So we end up with 4 over 4. So our axis of symmetry is x equals 1. The next thing we need to find is our vertex. We know that the x-coordinate is 1. And then we can plug 1 in for x to find the y-coordinate. So if you have 2 times 1 squared minus 4 times 1 plus 3, that'll be 2 minus 4 plus 3, which will give us 1. And you can double check that on the calculator if you want to. We already have 1 stored for x, so I can just go ahead and type in the equation, which is 2x squared minus 4x plus 3, and I got 1. You can also use the calculator to double check your graphs after you've graphed it. So there's my vertex. The next thing I need to find is the y-intercept, which is 0c. So it's 0, 3. I can go ahead and graph that. Then I'm going to use A to graph more points. So from my vertex, I went over 1 and up 2 to get the y-intercept. So I know I'm going to have a point on the other side of the axis of symmetry that's over 1 and up 2. And that makes sense since A is 2, so our graph is going to be stretched. Now our next point would be over 2, and then usually we go up 4, but we're going to double it and go up 8, which would be off our graph. Be somewhere about here. We can go ahead and draw the parabola. Now, we said that zeros are the same thing as x-intercepts, and there are no x-intercepts on this graph. So for zeros, I can write none. Domain, we already said that the domain of every quadratic is negative infinity to infinity, because it will continue on forever to the left and to the right. The range of this graph, the lowest point is here at 1, and then the graph continues on forever, so it goes toward infinity. And then for our end behavior, as x approaches negative infinity, f of x approaches blank, and as x approaches positive infinity, f of x approaches blank. If you look at the graph, on both the left side and the right side, the arrows are pointing up, so both of these are approaching positive infinity. Let's take a look at one problem where we're going backwards. We're going to write the equation in standard form of this quadratic. Now, just taking this graph and finding A, B, and C is rather challenging. So the easiest way is to first write the equation in vertex form and then do algebra to get the standard form. So let's go ahead and do it that way. So think back to the previous set of notes where we talked about A, H, and K. A is the same as A in this lesson. So if you look carefully, our vertex is at the point negative 3, 1, so that is H and K. Then to figure out A, you go over 1, and then we have to go down 1 unit to get to the graph. So A is negative 1. So if I write this equation in vertex form, I get y equals negative x plus 3 squared, because you always switch the sign of h, plus 1. So to write this in standard form, I need to square that binomial and then combine my like terms. So hopefully you remember that when you square a binomial, you are multiplying it by itself. So it's easiest to just write it out twice, and then we're going to multiply. Now the tricky part here is that we have a negative sign out front. So we need to distribute that negative sign to the first binomial only. So that'll give me negative x minus 3. The second binomial has not changed. Then I'm going to double distribute to multiply these two binomials. First, I distribute the negative x So I get negative x times x is negative x squared. then negative x times 3 is negative 3x. Then I need to distribute the negative 3. So if I distribute negative 3 times x, it's negative 3x, and then negative 3 times 3 is negative 9. And then don't forget to bring down this plus 1. Then I can just combine all my like terms. So I have negative x squared. Then if I combine the negative 3x and the negative 3x, I get negative 6x. Then negative 9 plus 1 is negative 8. So that is my equation in standard form. If you want to double check your equation, you can always type that into y equals in the calculator and see if it gives you the same graph that you started with.